we're gonna solve with substitution. So, for this chapter, it is incredibly important that you follow the directions. Because if I were walking down the hall and found this system of equations, I could solve it lots of different ways and get the right answer. But the point of this chapter is for you to show mastery of all the different ways, so that when you find a random problem, you think, oh, substitution is the easiest, or elimination, or Kramer's rule, or whatever it is. That's our goal. So we're going to follow the directions. X squared minus 9 equals 0. So we are substituting that in right here. And then what do we know about that?
Different squares. X minus 3.
X plus 3, X minus 3. So X equals negative 3 or positive 3.
Can you just do plus minus 3?
No.
No.
Because this is not the answer to the question.
Yeah.
Remember, when you solve a system, your answer is ordered pairs. You are trying to figure out where that equation crosses that equation. There are two equations out there, curves, and they're crossing each other. And we're finding out where that happens. All we know right now is that X is either negative 3 or positive 3. So I'm going to come right here, right here. If X is negative 3, then Y will be 9.
9 again.
And if X is positive 3, Y is also 9. Now normally, these two numbers aren't the same. So we'll write them as two separate ordered pairs, just so we're clear that we have two distinct answers.
Really?
All right, next one. Another substitution. So, I don't know, how about adding Y to both sides over here? And then plugging that in here. So 3 plus Y minus Y squared equals 3Y. What are we going to do with that?
What? Y squared. You set it up 3y minus 4y.
Isn't it a quadratic?
Yeah.
All right, so I like my Y squared to be positive, so I'm going to add it over here and make it positive.
Yeah.
I'll subtract that Y and subtract that 3. How does that look? Just rearranging.
That's good. Yeah. That's really good.
Collecting like terms. Now what?
Y plus 3 minus 4.
I'm either going to factor it or use the quadratic formula, right? Whatever you want. I think it does factor plus 3 and minus 1.
Yeah, no, what? 100%.
So again, two different answers. This time they are Y values, so make sure when you put them in your ordered pair, you put them in the Y spot. Those are Y values. And then if Y is 1, it looks like X is 4. And if Y is negative 3, it looks like X is 0. Substitution. Good? Yes. Oh, shoot, more substitution. All right, we don't need to do all of these. I'm not going to do those other ones. Oh, I better do the next one. I better do it. All right, so here we go. X equals 3y plus 6. And then I'm going to plug that into my second equation. So negative 2, 3y plus 6, plus 6y equals 4. Does that make sense, everyone?
Yeah.
So, what am I going to have? Negative 6y minus 12.
The 6y's cancel each other out.
Negative 6y minus 12 plus 6y equals 4.
It's just not possible.
Negative 12 cannot equal 4. So therefore, there is no, and I'm gonna say intersection, because remember, what is my goal? When I solve a system of equations, I wanna know where they cross. So whatever shapes these are, they're not crossing. They could be parallel lines, they could be, you know, a parabola, a line or something, that just will cross.
Can you just do the zero with the line? Or did I do that?
Yeah, that's all right. I hope you understand when you get the word problems, that you need to recognize that means there is no answer. Yeah, there's no answer. Okay. All right, number 2. Now we are solving with elimination. Okay? You guys have done this before. We don't need to do all these examples. You know what it is. So, solve with elimination. What does that mean?
Set
I did.
it times by a number negative.
Guys, Sam, Dan, Matt, focus.
Try to solve up and down, basically.
So, our job is to add these two equations together, but when we add them, something is eliminated. If I add them right now, I get 3x, negative y, and 5. Nothing got eliminated. So I need to do something. Not substituting, I'm eliminating.
Oh, it's solving.
If I multiply,
The bottom.
well, I multiplied the top row by 2. Are there other options? Yes. But what happens when I multiply the top row by 2?
4y against that.
4x plus 2y equals 20. Notice everything times 2. Now, when I add my equations, my y's disappear and it looks like x equals 3. Then, just like before,
Plug it back in.
I got, this time there's only one answer, x is 3. So I'm gonna go back and plug it in to something, one of the problems here, and I'm going to get a y value. So 6 plus y, did you get 4?
Yeah.
And so your answer is 3, 4. So again, what that means is, if you were to graph these two equations, they would cross at the point 3, 4. All right, let's look at B, because it's a little different. Not much. But what are we gonna have to do if we must use elimination?
Multiply by 3 and then multiply by negative 4.
Exactly. We're gonna need to multiply both equations this time.
Negative 3 in the top.
So I heard a suggestion, negative 3 on the top, 4 on the bottom. So negative 12x, 15y, positive 69.
X equals 2.
Hang on.
I'm not doing this, man.
So 31y equals. Okay, you got
I did
x.
X.
I got y
Yeah.
equals 3.
Yeah, I did X.
So Dana
So we just convert that to 3?
multiplied the top one by 4
Yep.
and the bottom one by 5.
Yep.
And he got rid of the y's. I did the x's. We both, no way's better than the other. We both now have to go out and plug in. So if I plug in 3 for
Negative 2.
y,
Careful.
I get negative 2.
That's good.
Is that what you said?
Yeah.
Okay. So negative 2, comma 3.
Yeah, negative 3. Oh, I got a positive. I got a positive.
All right, let's do C.
Right. Yeah. Okay, yeah, I know that.
Negative.
See? we didn't see?
Yep.
What's your problem here? Okay, let's cancel out, no solution.
So let's multiply by
4.
2.
2, negative 2.
So 4x minus 2y equals 6.
Well,
Now,
we're canceling out.
this one is not no solution. Because remember what happened in the last problem? We got something like 4 equals 10 or something like that.
Yeah.
That means no solution.
This
That
would be
means
all,
they don't cross.
all real.
This
All
one
real.
literally says 0 equals 0, doesn't it?
Yeah.
Which is true. Always. So these two equations are the same line. Remember, you are looking for the points where they intersect. These two lines are laying right on top of each other. Okay? Caitlin?
What's the difference between saying same line and like all real numbers?
Okay. We're looking for the points where these lines intersect. If I drew them, I would get a picture that looks like this. They're right on top of each other. All real numbers is all of this. Is all of that part of the answer? No. Only the points on the line, and there's lots of them, but all of the points on the line are the answer. Okay? All real numbers is wrong. Okay? All right. Now, we're going to skip number 3 and go down to because number 3, note there's no directions. So you could solve that one doing whatever you wanted to, right? I'm going to skip it, and now we're going to do vocabulary. Okay? Here we go. We're getting ready to start. And those of you whose intention is to take finite at some point, pay attention, because there's a lot of matrices in finite. Okay? There's a lot of matrices. So,
What does that homework do?
that'll be due on, let's say, Thursday, Monday. So your 7-1 homework is due on Monday. But it's substitution and elimination. Give me a break.
Yeah.
All right. What is a matrix?
A matrix is a line that never crosses the point where you intersect.
A rectangular array of numbers arranged in rows and columns. Okay, so I am going to give you an example of a matrix. Actually, I'm going to put a couple of them up here. So somewhere maybe over here in your margin area, here are your examples. Matrix A.
It's on the next page.
A rectangular, yeah, but I want to do vocabulary in terms of these. Okay, so I'm making these up just to help explain what all the vocabulary is. Okay, so just add these over here to the side. This is matrix A, and then I'm going to give you a matrix B. Okay. These numbers are completely random. Now, when you use a matrix in a problem, you'll get the numbers from the problem and they'll all make sense. I just totally made these up, all right? There's nothing special at all here. But these are two examples of matrices. Rectangular arrays of numbers arranged in rows and columns. These are the rows. Rows are like in the bleachers. These are rows. This is a row. This is a column, like the White House. Okay? When I talk about the dimensions of a matrix, the dimensions are rows by columns. This is not a time sign. It's rows by columns. Like if you go to the lumber yard and buy a 2x4, That's what this is, rows by columns. So, what are the dimensions of matrix A?
2 by 3.
2 by 3. How many rows? 2. How many columns? 3. This is a 2 by 3. Now, what's this one? This is a 2 by 2. That's what we mean by dimensions. Now, number 3, or C, square, that should be an X, square matrix. A square matrix, what do you think a square matrix is?
Is it even?
It has the same number of rows as columns. So is A square? No. Is B square?
Yes.
Yes. You can do things with squares that you can't do with everything else. Squares are kind of special. Alright? Entries or elements, 2 words for the same concept. Matrix, rectangular array of numbers. The numbers inside the matrix are called entries or elements. So this is an entry. This is an entry. That's an entry. These are called the entries. Alright? If, for some reason, I want to talk about this number right here, I would identify that number by using a little case a, lowercase a, because it's in matrix A, and then I would put a subscript on it that says 1, 2. That is not a 12, that is a 1, 2. A sub 1, 2 means look in matrix A, first row, second column. So in matrix A, first row, second column, that is the number 2. Got it? So that's how I talk about entries. What would B sub 2-1 be? B sub 2-1 would be 0. Second row, first column. Everything we do is rows, then columns. Think Roman Catholic, row, column. So when you see a 2-1, that's row 2, column 1. All right? A scalar. Anybody in here in physics? What's a scalar? You've heard that name before, that word before.
Scalar?
Huh?
I don't know if I've heard.
Oh Lord, I know you have. A scalar is just a real number, So, if I do this, here's matrix A. If I do this, A is a matrix, but 2 is a scalar, okay? So this is scalar multiplication. I multiply my matrix by a scalar. We'll talk about how you do that in a minute, it's easy. Equal matrices. What are equal matrices? Any idea? Do you think A and B are equal? No. All right, so what would make them equal? So if you're going to be equal matrices, you have to have the same dimensions. Would you agree with that? That a 2 by 3 can equal a 2 by 3. Now, would all 2 by 3s be equal? So if I made up another 2 by 3, would it be equal to this? Are these equal?
Yes. Oh, no.
No, they're the same size, but they're not equal. Because why? They don't have numbers in the right spots, right? So to be equal, you must be the same size, have the same dimensions, and you must have the same corresponding entries, which is just a fancy way of saying you gotta have the same numbers in the same spots. That's how you be equal. You are equal. You are exactly the same.
Yep.
Transpose. We do not have part of my training, part of my class I had to take was linear algebra. And it was a whole semester of matrices, okay? That's it. I mean, doing lots and lots of stuff. So there's a lot to this. We don't have time for all of that. I'm giving you basic vocabulary. If we want to talk about the transpose, let's do matrix A. The notation is this. Depending on the book you're using, that might be a lowercase t. It doesn't matter. If it's like an exponent position, but it's a t, that means transpose. Here is the transpose of A. Tell me if you can see what happened when I transposed the matrix.
Rotate it.
So, notice in A, row 1 is 1, 2, 3. In the transpose, column 1 is 1, 2, 3. So what is the transpose? It's just like music, Julian. Sorry about that, Julian. When we transpose, we switch things around. So that's what we're doing here. Row becomes column. All right? So what would B transpose be? What would B transpose be? 2, 4, and 0, 3. Like that. Easy. And then the last vocabulary word, what is the trace? Now, the trace has a trace and transpose, both start with T, and we tend to get them mixed up sometimes. But remember, transpose is like an exponent position. Trace is written out in front. TR, that means trace. We're finding the trace of the matrix. A does not have a trace because in order to have a trace, you must be square. You gotta be square. So A is not square, so therefore it has no trace. Now, any matrix can be transposed. Anybody can be rows become columns. That can happen anyway. But a trace has to be square. And the trace is, you know how disrespectful you guys are being right now? Not only to me, but to your classmates who are trying to pay attention. It's really not funny, Dana. The trace is simply the sum of the entries on what we call the main diagonal. So that's this diagonal right here. So I simply add those together, so the trace of B would be 5. Now obviously, if the matrix were bigger, I would be adding more numbers, but it's always that diagonal right there. That's called the main diagonal. We'll be doing operations with other diagonals, but this one is the main one.
So it has to be square.
Beginning to end, it's gotta be square. So the trace of this matrix would be 15. Now, believe it or not, there's value in knowing the trace. There are things you can do with that. We're just finding it right now. So, did everybody understand how I got the trace?
Yes, ma'am.
All right. Let's see. All right, I think I'll stop there. That's a good stopping point. And then we will continue our review. I hope you took good notes because we're going to need all that notation as we move forward. All right, I'm going to turn back. I think I have a few papers to turn back. And I want you to be figuring out what we need to practice. in our remaining time together.
We're doing this today?
That can be, there's something on there you wanna do.
Well, I just was saying that because we already did the other one.
So as homeworks and quizzes are coming back, you might want to ask a question about something. Oh.
Studying root and house food project. Remember when you're, this is, you found that out?
What I said when I was
I didn't know we had a
Yeah, I agree.
It would never study. Never study science.
That's what I did too.
And then the other spherical is I like to. I get it all right. You add all the sides together. Yeah. Oh. You try to add by. Why'd you get everything you put in flat one? How'd you get it? It's like the same. Asking to find
That is your partial credit. 1.5 points is your partial credit. Yeah, so, well, no, that's finding area, so you would do, I think one half, they do,
Oh, yeah, you do. Why they get it? This year, it's so it's area you want to have. Do 10 squared plus 60 squared minus 2 times 16 cosine 4. Yeah. Did you root it? I don't think you rooted it. Oh, yeah, you did.
That makes
Oh, you did
Wait, how would I get?
You look bad, idiot. You look bad.
I think everyone got one hand.
I just did that.
All right, friends, so I just turned back a whole bunch of stuff. What kind of questions? Do you have about any of that, or something you found on a worksheet? Either, I don't care what, this is your review time you wanted, so let's
They're due.
Use
Yep.
it wisely. Okay, now,
Number 2 on quiz 5.5. Part 1.
5.5, the colored in part or the empty part?
Empty heart.
Empty part?
Yeah.
Number 2. All right, question says,
Negative space.
how many triangles are possible if A is 58, side A is 10.3, and side B is 9.7? Okay? So we want to know how many triangles are possible. So I need to change myself into degrees here. All right, so this is clearly a law sign problem. So sine 58 over 10.3 equals sine B over 9.7. So I'll cross multiply, divide, and if the sine B equals sine B equals 9.7 sine 58 over 10.3.
When you sign, negative sign.
And I have to inverse sine that, right. So second sine,
Yeah, 52 degrees, right?
7 sine 58 divided by, so I got 53.75 basically.
Yeah, it's
All right, so I know, the question is, how many triangles are possible? So I know there's at least one, right, because I got an answer. So then I gotta figure out, okay, is there another triangle? Could there be another possible answer to B?
No.
Well,
53 minus 1.
there is one, but will it work? Let's see. It would be 126.25.
Yeah, it doesn't work.
And that doesn't work because these two added together
More than 180.
are already more than 180. So therefore, how many triangles are possible? Well, just the original, just the original. And the work you have to show, I need to see this angle and I need to see this angle. That's how I know you know what you're doing, right? Okay, anybody else get a paper back, either quiz or homework or something that Joe Garber.
Number 2 on the empty heart 5.6 squares.
5.6, empty heart, number 2, find the area of triangle LKF.
Yeah.
Those are my initials, I'm an egomaniac. Alright, we're gonna find the area of this. So since I know all 3 sides, I'm going to do zeros for them. So I'll add up all the sides. What do I get? 46 for my perimeter. So that means my semi-perimeter is 23. And then I'll take 23 minus each side. So that's going to be 6 on that one, 8 on that one, and 9 on that one. And those can be in any order. Then I just do that. And I got 99.68. If I'm rounding to the nearest hundred. Caitlin?
Could you do, number 3 at homework 5.5?
5.5, homework number 3. 5.5. Homework number 3. Okay, so what's happening here?
Because the Lakers are losing.
Two observers are 400 feet apart on opposite sides of a tree. So here's the tree. And this whole thing is 400. So we'll call this guy A and this guy B. All right, Caitlin, you with me? Okay. The annual elevation from the observers to the top of the tree are 15 and 20. find the height of the tree. Okay? Alright, so what I would suggest is, okay, so obviously we got triangles all over the place. We've got this little right triangle, we got this little right triangle, and then we have the whole triangle. Now, what do I actually know about this right triangle? Two things. Two things I know about it. Actually, I know two things.
You know it's
This is
55.
15, and I know that's 90. So I can find that angle. But having all three angles is not enough to solve the problem. Can't use law sines or law cosines if all you got is angles. Would you agree with that? Same thing with this one. So there is not enough information in the problem to use either one of these small ones. So right now, I am gonna have to go with the big triangle. I know that this angle up here would be what, 145, did I add right? And then, doesn't matter which one, I could find side A, let's say. So sine 145 over 400 equals sine 15 over A. I have taken out my tree, and I'm looking at the whole big triangle. Can I find A? Yeah. So 400 sine 15 divided by sine 145. So this is about 180.450.
Yeah.
But I'm gonna write that down, but that number's right here where I can use it again, right? It's just staying right there. Now, Caitlin, I will put the tree back in.
Sine 90.
Keep in mind, when you randomly drop a perpendicular in, that does not bisect that angle. So I am gonna just erase that. I don't wanna get confused by that. I don't know, I know they are together 145, but I know nothing about them individually. However, now I do have a side,
Sine 90.
so I can do my law of sines, or SOHCAHTOA since it's a right triangle. But I can say sine 90 over the number that's in my calculator equals sine 20 over h. So I'm going to take the number that's in my calculator times sine 20 and divide that by sine 90, and this is 61.73. So, Caitlin and everybody else, if you are trying to find something in a triangle, you gotta have one side. You can't do it with just the angles. So you gotta figure out how am I gonna get a side. Okay?
Okay.
Alright, who else? Who else? Joe?
Number 1 on the 5.6 quiz.
5.6 quiz. Joe, did you prepare it all?
Yes, I did. I actually studied out.
Okay, so Joe, our job is to find side n, right?
Yeah.
Okay, that's the law of cosines, just straight up. What does law of cosines look like? N squared equals 10 squared plus 16 squared minus 210 16 cosine 54. It's just a straight plug it in. What do we have to always remember to do when we do the law of cosines though? Square root. Finding the side of this, you got to square root, you have to get it all typed in. Type it in, square root.
That's what you forgot. Wait, hold on. Yeah, the only thing that Joe didn't do right is square root. He didn't square root it.
I think I did everything else right.
Yeah,
No,
Joe
you
gets
did.
partial credit, yeah.
That's awesome, but
Sorry. What do you want?
first
You're
of
on the right
all,
track.
so Joe, if you have sides in a triangle of 10 and 16, and you're telling me the other side is 160 or whatever you said, does that even make sense?
Let me see what I had my answer as. My answer was 21.16.
Okay, then he must have
Yeah.
square rooted, but he did something wrong.
He did something wrong. You want me to do it for you?
No, I don't think so.
check it. I got my one picture.
Yeah. And then if you get 126 and 58, if 126 and 58.
Oh,
Okay.
yeah, that one.
Homework 5-6, number 4, was a trick question.
Oh, really?
Yes.
Which one?
Let's read it carefully and look at it and figure out, because a lot of you,
Oh, yeah, yeah.
so who got an answer to that one in a moment?
Which one?
Okay, well, oh, that's way wrong. Okay, so,
Oh, you're good there.
so, is that 289? Anybody else get 289? Yeah, okay. So you did everything right, but you answered the wrong question. And it was tricky. I would definitely deem tricky. So let's see if you can figure out why it's tricky. Find the area of a regular nonagon circumscribed about a circle of radius 10. So, what our other problems were, we had a circle with our figure inside of it. That's called inscribe. What does this one say? We're circumscribing it about the circle. So you have a circle, but your 9-sided figure is around it. So you connect these outside the circle. I'm doing a terrible job. Okay.
When the sword's done, artist.
I'm not an artist.
Yeah, these are
It's
tricky.
alright, I'm not even.
These are tricky.
We're good, brother.
I lost track of how many I had. But anyway, the thing's outside, okay? So what difference does that make? Well, you're still gonna have triangles, okay? And there's still gonna be 9 of them. This picture's really bad, but you're still gonna have 9 of them, okay? The central angle is still going to be 40, because anytime you make 9 chunks out of 360, it's going to be 40. Now, what's different is, we're finding the, so what's different is, when I connect these, if I want to find the area, am I doing area or perimeter?
Area.
I find the area, I have to be careful because the radii, this picture's so bad. I mean, let me redraw my picture. Okay, so there's the inscribe. That is the, if you got that number that I said, that's what you get. I need the one that is outside. This is what it looks like. It is tough. But the problem is, here's the difference. When you drew your radius, the radius goes to here.
Yeah.
So it doesn't go to a vertex of the polygon. It goes to here. So here is a triangle. This segment is outside the circle. Now, we know that the radius, which is this right here, is 10. We know that this triangle is isosceles, so these are 20s. I need to know how long long this is. Okay? So that right there, how long is that? Well, this is a right triangle. So you could find that by saying something like what? Cosine 20 equals 10 over x. 10 over x. Now, as soon as you find that number, whatever that is, that will be this right here. So what will the area of that triangle be? Side times side times sine of 40, the whole triangle, and then times that one by 9. All right, that was a trick question. I won't put that on your test. Or quiz, whatever.
Question.
All right, you have time for another one. That one was tricky for sure. Do we have time? Do we have time for another question? What is it?
5-6 homework number 1.
5-6 homework number 1. Solve the triangle. Now, what does that mean? That means find everything we don't already know. So let's find angle S first. It doesn't make any difference, but there are problems where it actually does make a difference. So let's just find the big one first. All right, we're gonna find the biggest. And the biggest would be S. Would you agree with that?
Yeah.
Law of sines or law of cosines, those are my only two options. Gotta be cosines. So here we go. 12 squared equals 10 squared plus 11 squared minus 2, 10, 11 cosine S. The problem Joe asked about a little bit ago was the law of cosines. But in Joe's problem, we just typed all this in because we could. Here you can't because you got a variable out there. So you got to do it logically. So I know 12 squared is 144. I'm going to add these two together, so it is 221. I'm going to multiply these, which is what? 220. I'm doing that in my head, I hope it's right. I added these two together, right? Multiply those. Now, how do I go about solving for cosine S? I don't divide by anything. What do I have to do first? I gotta subtract 221, negative 77. Now I can divide.
77 over 220.
So cosine S equals 77 over 220.
Inverse and converse.
So then I'll second cosine, inverse
It's gonna be about,
cosine.
8.49.
So S is 69.51.
Never mind.
Tyler, are you with me? Now, as soon as you do that, Tyler, as soon as you do that, then, if you want, now you can do the law of sines. If you'd rather, Tyler, could I repeat this process for angle C? Yeah, exactly. Regardless of how you do it though, to find the third angle, just add them up and subtract from 180. Don't do any trig for the third angle. All right, one more. All right, when you walk in here tomorrow, you're gonna have 30 minutes for the quiz. No whining and complaining. You guys that hang out all the time late, no, because we're starting after 30 minutes. After them all handed out, 30 minutes, we're going to jump in. To our chapter 7.
Baby girl. Baby girl.
Shouldn't be, but I'm like kind of stressed about it.
Grinding out 500 years. Dude, now you're like thinking about it.
That should make that much.
She's making you turn.
It looks like, Lamont, you did everything, you set everything up right, so it must be something